Today, we are going to look at a research from a quantitative point of view. Now, the last time you could remember, you have to gather data. So we've gathered some data, and I'm sure I've given you that data, which is known as Burukutu gene bitters. Now, before we do that, I want to walk you through some things, just as a story. Suppose you want to write a thesis, you want to write a project, you want to write a consult, an executive summary, anything. You are writing a journal paper, dissertation project, anything. And let's assume that the title of this thesis is The Determinants of Demand in the Alcoholic Beverage Industry in Ghana. Now, and then you've added, because you have seen a lot of papers actually talk about determinants of demand, but you want to look at the specific impact of location, occupation, and religion. Okay. Now, normally, you would have indicated in your gaps, in your literature introduction, in your thesis introduction, that even though previous studies on the subject have looked at several things like this and that, nobody has, or they have not considered the potential effect of location and occupation. And you may have taken references from other studies to justify why inculcating occupation and location into determinants of demand analysis is very important. So that would have settled the gap and would have actually motivated the reader to want to read more. You would have even probably said that few studies have considered religion as a determinant of demand. You would have said that even though some have looked at it, like they've looked at Christianity and they've looked at Mohammedanism, majority of studies have not even looked at the impact of Buddhism, to the best of your knowledge. You could have said something like that. You could have also identified some potential methodological gaps in the work. For example, you may have said that previous studies have used hypothesis testing, they've used ANOVA, analysis of variance, they've used correlation, but to the best of your knowledge, they've not looked at a regression. And so that is probably the gap, the methodological gap that you are bringing on board. So you could have mentioned a couple of gaps in there. Okay. Now, question. My destiny is frozen.
Oh. Collect data on Burkutu Ventures, a local gin distillery that is concerned about the demand for its gin bitters.
Hold on. My pen is
demand
reading.
In most of its retail
in a way I've not
shops
requested it to
new
read.
entrants into the market. Management is even concerned and wants to determine those predictors that better explain the quantity demanded of gin bitters,
It's reading,
apart from the price.
but I've not requested it to
gin,
do any reading. So just
of the determinants of demand, the word identity and price of complements of gin. C. Average real income of customers. M.
Again. So you would have done all of this. And from the problem statement, you normally would state your contributions, objectives, and the research questions. You would have reviewed the literature, critiqued the previous studies, and those other studies. You would have gathered data. You would have gathered data to answer some kind of hypothesis or research questions that you have. If you want to know how to do all of this, there's a document called How to Write Research Journal Article in Scientific Journal, MIT paper. You can look at it. Okay. So the data we have collected for this purpose is called Burkutu Ventures. It is a local gin distillery that is concerned about the demand for the gin prices. Now, demand in most of the retail shops has been hard hit by new entrants. So competition has heightened and management is concerned and they want to determine those independent variables, those predictors that can better explain the quantity demanded of gin bitters. Now, what are the quantity demanded of gin bitters? If you have done economics before, the factors of demand are many, but then the key determinant of demand is price. So price is actually a movement along the demand curve instead of a shift of the demand curve. So price is a key determinant of demand. But apart from price, what other things? Well, one of the things we know in the literature is complement price. So here we are considering the complement price of gin. Now, who can tell me some of the complements of gin, first of all? What are the things? Suppose you are drinking akpeteshi. What are some things that can go with akpet? Okay, which you might call is a complement. You can give me one. Okay, you got to have the entire knowledge about what you are doing, okay, so that you can understand the research well. So who can give me a complement of this?
So, Doug, I know some people take meat or kebab when they are taking alcohol.
Perfect. I don't know if that is one. What else? What else? Apart from kebab, what else is a complement of gin? Yes, Ramatu.
Granuts.
Granuts, good. What else? Apart from kebab and granuts?
Cigarettes.
Cigarettes. Hey. Yeah, baby. No. Okay.
And pepper soup.
Pepper soup. I agree with that as well. Okay. So all of these are complements of gin. Another thing that can affect the demand for alcoholic beverages like Brukutu gin. Oh, by the way, if you want a video on Brukutu gin, you should click on this link. It will remind you of an advert of that. The average income of the people can affect the demand, because if Brukutu gin is actually considered as a normal good, then an increase in their normal good will increase the demand for the gin. Okay, but if it's an inferior good, an increase in that income level of the customers would decrease the demand for that gin bitters. Okay, so this is a data set. Okay, we're going to see the data set in Python very soon, but this is a data set. So the first shop, okay, all of these are in 1 year. So this is a cross-sectional data, by the way. The first shop here, the quantity demanded, the bottles of quantity demanded was 160 bottles. Okay, the price is 16, see this. And then you have the complement price to be 60. But you may notice that the complement price in most of them is high. As to exactly what that complement is, we have not indicated. So you wouldn't know what complement it is for now. The income of the people is this amount. The average income of the people, okay, is considered to be that amount. So for the first shop, the income is 14.5, but for the second shop, the income is 21.5. So the second shop, the average income is more than the first shop. They are all in an urban sector, but the third shop is in a rural area. So the location is either urban or rural. That kind of variable, where you have one being something and the other being the other, where the one is the presence and the zero is the absence. So you can let urban be 1 and then let rural be 2. Such kind of variables are known as dummy variables, categorical variables. Okay. So, but the levels for this location are just what? 2 levels. Anytime you have 2 levels, the dummy is 1. Anytime you have 3 levels, the dummy is 2. So the dummy is always 1 less than the level. Write it down. Okay. So if you want to know the number of levels, classifications, clusters, the dummy is always 1 less than the level. Another factor that can affect the demand for akpeteshi gin is the occupation of the people. Okay. The people are teachers. So if you look at the first shop, most of the occupation, or the average occupation of the people is teaching. But the second one, most of them are fishers. The third one are also teachers. Okay, and then it goes on. There are traders also along the line. That is 3 levels. Because it's 3 levels, we expect the dummy to be what? To be 2. The last one is the religion of the people. It's believed that, the religious background of the people can make them demand a lot of akpeteshi. Okay. So Muslims, the first shop, majority of the people are Muslim. Okay. The second, majority of them are Buddhist. The last, majority of them are Muslims. The third one. So these are typical examples of the data set that you have. So all that I said are here. So you were told that location affects the demand. And you have been told that the location can be split into LU, being urban. That is, LU is 1 if the area is urban area, or 0 if the area is rural area. The dominant occupation of the people are 3 of them: teaching, fishing, trading. Okay. And OT is 1 if the people are teachers, okay, or 0 otherwise. OTR is 1 if the people are traders, or 0 otherwise. So let me ask you guys a question. If you check carefully, the 0 is always the reference category. The reference category is the one you always talk about, or you always talk in reference to. So for example, if I say that these people are in an urban area, I'm talking about 1, which is a presence. So you should automatically tell you that they are not in a rural area. Suppose I say that this person is a male. That should automatically tell you that he is not what? A female. So the female, the moment I say he's a male, I am talking about he's a male in reference to he not being a female. But when the levels are 3, like occupation, fishing, and trading, where you have 3 levels, for you to know which one is the reference category, it is the one that is giving the 0 otherwise. So you can see that here I spoke about occupation being teaching. Okay. I also spoke about occupation being trading. Okay. And then I didn't talk about the other occupation. What is the other occupation? Fishing. So that means that fishing is the reference category. What does that mean? It means that anytime I say that these particular people are teachers, I mean they are not what? If I say these particular people are teachers, I mean that they are not what? I mean they are not what? Come on.
Fishermen.
Yeah, they are not fishers. Or they are not fishers. Okay. So, and each time I say that the people are traders, the same way I'm saying that they are not fishers. So fishing becomes a reference category. Okay. Now, with the same thing, when you go into the religion, we have Christian, Muslim, Buddhist. Now, who can tell me which of the religions here is a reference category? Which of the religions you see here is a reference category?
Christian.
Yeah, I know you have guessed. Now, the moment you start saying it and you start getting it wrong, you are making it easier for somebody to guess correctly. Which religion is a reference category?
It's those that are not Christian, are not that is Buddhist and Muslims.
Yeah, but then we always have one as a reference category. So which one? You got to read the instruction here.
Sir, Buddhist.
Buddhist. You see, when you that one and I will tell but you have to always participate as quickly as you can. It's Buddhist because you can see that Christians were giving 1, which means they are present. Okay, and then Muslims are giving 1, which means they are present. Okay, so if the one that was not, even though you were told that 3 of them are there, the one that was not giving any 1 is Buddhism. All right. Our job today is very simple. We are going to do the first part. We're just going to generate summary statistics. That's it. Summary statistics. Now, when we say summary statistics in quantitative analysis, what does it include? Give me as many of them as possible as you know. Everybody, you raise your hand, you mention. Raise your hand, you mention. Give me one. Joshua.
Me.
Thank you. Next. Forgive.
Mode.
Next.
Standard deviation, variance, covariance, median.
Joshua, you are mentioning all.
Yeah, Joshua.
This one is on. Sorry.
So that he becomes the smartest person in the room. Yes, Hubert. Tell me the ones he's not mentioned.
The interquartalism.
Hey, Kofiadu.
Say again.
What is interquartalism? There's nothing called interquartalism.
No, I mean, I said initially interquartal. I was just, you know.
Interquartal what?
Interquartal ranges.
Okay. What else?
Skewness.
Skewness. What else?
Ketosis.
Ketosis. What else? That's all. That's all you know. Think about all of them. Because you're going to use this thing to develop several machine learning models. Okay. All right. So you have the harmonic mean, you have the geometric mean, you have the arithmetic mean, you have the weighted mean, you have the coefficient of variation, and several other things. That is what we are going to look at today. So let's take a couple of them. Okay. The mean. Normally, I'll go through these a lot with the babies, but you guys are not babies, so I'm not going to go through deeply. But I'm going to show you some unique features of some of them. For example, if you look at the mean is the average, but actually the mean is not the average. The median is also the average. The mode is also the average. But the mean is the one considered to be the main average. Okay. Now, when do you use the mean instead of the median? Who can tell me? When do you use the mean instead of the median? Since they are all averages. Does anybody know? No? You use the mean instead of the average when your data is normally distributed. Write it down. You forget because I asked you these things. Use the mean instead of the average when the data is normally distributed. That's when you use the mean. But when do you know that the data is normally distributed? A normally distributed data is a data set that is symmetric. What do we mean when we say the data is symmetric? Okay. What we mean by that is that majority of the data points are picked at one group of numbers. So when you take the data, if you take, for example, the scores of students, majority of them will score around a certain figure, sometimes between 60, 50, 55, 60, 65, 70, thereabout. Majority of them are scoring around 60, plus or minus 10, 60, plus or minus. So majority of them are there. Then few will fail, few will have the extension. The majority of them are in the same. So scores of students grades, student scores are normally distributed. Ages are normally distributed. The majority of people are around similar ages. The height is normally distributed. People who are about 30 years are all of similar height. Okay. Height is normally distributed. Weight is normally distributed. Okay. Income levels of people are usually normally distributed. You remember the data types, the continuous variables, the ratio variables that we looked at, most of them are examples. So the mean is used when your data is normally distributed. So when you check your data, and it's usually normally distributed, and we have a test for doing that, the Shapiro test. Okay. Once you're able to use that to determine that a particular variable is normal, then you will take the mean of that. Otherwise, if it is skewed to the left or to the right, meaning the majority of the data is not in the center of the distribution, but is in the right tail or left tail, such kind of data, then you have to use the median to assess analysis that you want to do with it. Okay? You have to use the median. Also, when there are outliers in the data, the median is good to use because it's very robust to outliers. I hope you know outliers. Who can tell me the difference between an outlier and abnormal observation? An outlier and an abnormal observation. Outlier. and influenza. Let me use that word. An outlier or influential observation. The difference between an outlier and an influential observation is that an outlier will be on the same level as the rest of the data, but it is far away removed. But it does not influence the entire fitted line. I'll give you an example here. So when you have this data, as you can see here, okay, and then you have this data, okay, you see all of this data here. And then you have one that is also here. All of these are here, and you have one that is here. Let's compare that with this one. Okay, you have all of this here. Okay. Okay, and you have one that is there. If you look at the first one is an outlier, but it's not an influential observation. The second one is an influential observation, and therefore is automatically an outlier. Take note. Why? Because the second one, it can shift everything to its side. If you try to calculate the mean, it's more likely to shift everything to its side. But the first one, if you draw a line, a straight line through, it might still pass through that one. Even though it's separate, it still passes through, just as it's passing through this one. You got to know this. When we come to regression, then you can appreciate it even more. So in short, the mean is good when you have, you see, because when you take the mean of 2, 8, and then say 3. That's 5. Okay. So that's 13. Let me make the 3 that. What is the mean for this? 15 by 3 is 5, right? So the mean is 5. Now, take this one too. 2, 50, and then 5. 2, 50, and 5. So you have 57 divided by 3. That is a mean. Okay. 57 divided by 3. That is 19. So here the mean is 5. Here the mean is 19. But you can see that this very 19, almost all of them will not agree with that number. 2 is far away from 19. 5 is far away from 19. 50 is far away from 19. They will not agree. But if you take the first one, 5 is perfect to this. Okay. 8 is not even far away from that. 2 is not far away from that. So you all have the same kind of information, almost the same kind of information, but you can see that the second one, the mean is not trustworthy. Why? And that is because of this 50. This 50 is an outlier. Okay. So what do you do? What you do is that you take the median rather. To do the median, you need to arrange them in an ascending order, 2, 5, and then 50. And the median will pick the middle guy here, which is 5. Okay, who will agree with that? 5 will agree with that. That's cool. 2 will agree with that. 50 will not agree with that. So at least we got 2 of them agreeing with that. So when you have extreme values like this, the median will do some great work. That's just for you to know, because I've asked several of these questions. Next one, the mode. But the mode is frequently used. It's normally used for categorical data. In fact, you will see that whenever you are doing kernel density plots, which we shall do, okay, it's very useful. The mode, okay, it tells you the peak. That normal distribution that I just did here, that peak here is the most occurring. So if 6 is occurring many times, at the point of 6, it will pick up at that point. Very useful for categorical data. Categorical data are data that are not numerical. So if you want to know the peak in distributions, if you know how a particular data set is distributed, the mode is very powerful. Very, very powerful. What is it that is making this particular number consistent? The mode will do that magic for you. And then, of course, the standard deviation. Now, the standard deviation is how far away all of them are from the center. It's just like the variance. Okay. I'll talk about the difference very soon. But then the standard deviation is how far away. One major thing I want you to know between the mean and the standard deviation is that if the standard deviation, so let me just use this one. If the standard deviation is greater than the mean, that means that there's a lot of variability in the data. In other words, sizing matters. Size matters. Size matters. Okay. When you have the standard deviation being bigger than the mean, it means that size plays a significant role. Why? It means that some of them are too big, some of them are too small. So if it is a quantity demanded of gene bitters you're looking at, okay, and the standard deviation of quantity demanded is more than the mean, it simply means that quantity demanded, there are too many big quantity demanded, and there are too many small quantity demanded. That is why standard deviation is bigger than the mean. But if the mean is bigger than the standard deviation, it means that majority of the data points are closer to each other. What if it's 0? What if the mean, what if the standard deviation is 0? You can guess. If the standard deviation is 0, what does it mean? What does it mean? If the standard deviation is 0. Class rep, are you here?
Yes, I'm here.
Tell me. Tell me the answer.
I think it means that maybe all the data points are the same.
That's it. So you see, if I have not pushed you to the wall, you wouldn't have come out with what is your God-given knowledge. Okay. So it means that much of the data points are the same. So if you are all 50, 50, 50, the standard deviation is 0. So you should know this because this is very important for you to know the next step you are doing. Okay. Now, what about the variance? Well, the variance is similar to the standard deviation, just as the square of the standard deviation. The standard deviation is the square root of the variance. The standard deviation and the variance, both of them measure the spread. Okay, but there's something interesting about the two of them. Now, whereas the standard deviation is looking at the average deviation, average of the deviation. So first of all, everybody is deviating from the center. The average of that, okay, this variance is looking at the average square deviation. You need the variance before you can get the standard deviation. You need that. You need the variance before you can get the standard deviation. Both of them are still measuring the variability in the data set. Skewness. Well, the thing about skewness is that, what's skewness? Skewness. Oh, and by the way, yeah, let me see, skewness. By the way, the mean, you can have different kinds of mean. I spoke about arithmetic mean, very easy. That's the one we always know. There's also the harmonic mean, okay, which is a reciprocal of the average. And then geometric mean. I like the geometric mean a lot, especially when you're dealing with indices, consumer price indices, you know, sustainability indices, and things like that. This is good, geomean. Okay. Geomean is good when the data is non-parametric. Again, it means that when majority of the data points are skewed, okay, when there's a lot of skewness, geomean is good if you don't want to use the median. Okay. But let me go back here. Skewness. Okay. Skewness looks at the symmetry. Again, we've talked about it. Okay. When there's a deviation from the center, more deviation from the center, whether it is to the right or to the left, more deviation from the center, that is skewness. So when you have positive skewness, then it means you're talking about long right tail. Negative skewness is talking about long left tail. The mode is able to do well in showing you the skewness of the data very well. Okay, then range. Well, a range is very easy. The bigger value, the biggest value minus the lowest value. Very easy to understand. The range can also tell you the deviation from the center. Okay. It tells you a lot of deviation from the center, but it will pick the highest value and the lowest value. And it will tell you whether you are dealing with too many big things or too many small things. The interquartile range is just taking the quartiles, the first and third quartiles in there. That is interquartile range. Okay, very, very useful for outlier detection. The minimum absolute deviation, the mean absolute deviation, is the average of absolute deviation. Okay. If you don't want to use the standard deviation, it is one thing that can be used. But I'm more interested in the coefficient of variation. I'll talk about that in the practicals. The coefficient of variation is basically the standard deviation divided by the mean. Okay. That is a very, very, very useful thing, the standard deviation and the mean. Now, the coefficient of variation is used for volatility, okay, especially when you're talking about things related to volatility. The coefficient of variation is very, very powerful, okay, as far as volatility situations are concerned. So this is just to give you an idea or the essence of most of these statistics that one can actually deal with. Okay, now skewness. Yeah, I've talked about skewness. Okay, one thing about skewness is that it's difficult sometimes to interpret. So you use a graph to describe it. Skewness is telling you whether it's left tail or right tail. And then the peak is the ketosis. Okay. The peakiness. So something can be flat or it can be very, very long. But where it goes left or right, it can still be higher up there but left, or higher up there but right. Okay. But whether it's left or right is a skewness. Whether it is up or down flat is a ketosis. Very, very useful, if you want to determine outliers in the data set. Many people don't talk about ketosis because of how sometimes confusing it might be. And the final one is entropy. Okay, it tells you uncertainty in the data, especially when you're dealing with information theory. Okay, there's a lot of unknowns in the data. You use entropy. All right. So what we are going to do now, and all of these, I've given you the Python codes for them, for all of them. You will calculate these things in the exams. Okay, I'll show you. You will calculate most of these things in the exam, and you will interpret and compare most of these things in the exam. I'm going to now take it to the Python, and then we'll try and look at the data and estimate most of these things. So the first thing is that we have opened the data set, which I have called GIN. Okay. I have called GIN. I don't know why I wrote BP here, but you should edit it. Double click this and then change it to GIN data set. Okay. So that is what we are looking at. Okay, I have a similar thing here that I wanted to take note of. GIN data set. That is what we are looking at here. So the first thing I want you to do is to understand all of these codes. See, I'm doing this under the impression that you've already been taught all of these major libraries. So anyone that you don't understand, let me know. But the major one we are going to use today are just the first two. And I'm sure NumPy and Pandas, you know about them. Can you confirm that you all know about NumPy and Pandas?
Yes, sir.
Yes, sir.
Good. So now we are going to load the data set. All of these other ones, you should get to know them later on. Okay. So I have some questions for you, and this is what I want you to do. My question is very simple. Load the data set. Okay. It is a CSV file. And please confirm if it is a CSV file. If it's not a CSV file, just save it. If it's Excel, save it as a CSV file. I want you to load the data set, which is called gen, and then when you bring it into Python, call it df. So you're going to type a command here to be able to execute that thing. Can you do that? Do you know which command you have to type? Because I'm waiting for you to do that. And then if you are lost, I teach you, I guide you. What command do you have to type to load a data set? Who is the smartest person in this class?
Prof.
Yes. Theophilus.
So,
Amma.
There. So it's,
You don't know what we are doing, Amma.
I know. So it's
So why didn't you show up until I called you? Is there any particular reason why I need to call you before you show up?
No, please.
Well, the next time I have to call somebody, guys, I'll just have to fly. That's all I want you to know, because I don't need to be calling you guys and then nobody is responding. Like, I don't need to, you should be able to follow me. So I'm just going to assume and fly along. All right. Okay. So let's move on, because you got to participate. You got to be the one to even say that, I want to talk. You got to be raising your hand all the time to want to talk about what you know and what you don't know so that I guide you. Okay. So you got to load your command, okay, by typing df. Because what you're doing is that you've been told that you should label. All of these are questions I'll give you. You should load that you are doing this, and you're using a pandas command. So because you're using a pandas command, you type pd.csv. That is the name of the sheet that you are using. You do pandas underscore CSV. Sorry, did I say pandas? Sorry. Read underscore CSV. What have I done? pd.read underscore CSV into brackets. The name of the data is gen. So you bring your apostrophe, type gen.csv. Now close with a curly bracket. Okay. So this will load the data set easily for us. That's how you do your running. Now let's run it and see whether it's going to work. So click run. Okay. I have not loaded the pandas. So let me load the pandas. Okay. At the top here, I need to run this command to load the pandas. So let's load that first. Now, it's going to take some bit of time in my case because I have other libraries. Okay. I have other libraries here. So obviously, it's going to take some things to load. This star means that it's still loading. It's still loading. Okay, done. It's done. So now let's load the data set here. And yes, it has loaded.
No,
that's the question.
Seems I can't see your screen.
Guys, you all can't see my screen?
Well, for me, I can see it.
It's showing now at my end.
I can see.
I can see.
All right, so your colleagues have confirmed that they can all see my screen. So check your settings, okay? All right, now that you've loaded the data, okay, the next thing is to show the head the 6 rows and the tail of the data set. It didn't say the 6 rows of the tail, but the head should be 6 rows. So what command will you use to show the 6 rows of the data? Well, what you can do is you can type the name of the data, which is df, and then type head, and put into bracket 6. Close the bracket. That's it. And now let's run that and see. Okay? That shows the head of the data. It's a 6 rows, so 0 all the way up to 6. That is how you show the head of the data. So this means that your data is nicely showing the way you want it. But the second bit says the tail of the data. It didn't say the 6 rows of that. It just says the tail. So just type df, which is the name of the data, and type tail and do bracket. And that's it. Okay? And that shows the tail of the data set like that. You got to learn. Now, why do you need to show the tail? Because sometimes the data is quite big and you want to know the top part of the data and the bottom part of the data. So this tells us that we have how many observations? 40 observations, because 0 is counted. Done. Next thing. The next thing is asking you a question. Okay? And you have it here. But all of this question you can just. The question is, how many are categorical and how many are numerical? So who can tell me? Forget about the year and the shop. Okay, forget about the year and the shop. Every other thing, tell me how many are categorical and how many are numerical. Quickly, quickly.
Sir, we have four categorical variable, 5 numerical, 3 integer, 2 floats, and 4 character variables.
This one categorical and numerical. Let's stop there. Just categorical and numerical. That's all I want.
4 categorical, 5 numerical.
Okay. From what you see on your screen, is that it?
Yes, sir.
Anybody else? I didn't say dummies. I said categorical. So you have 4 categorical, which are these, and then you have 4 numerical, which are these, and then you have 3 categorical. That's it. Okay. The levels are the things that come as the difference, but that is how it's supposed to be. Okay, next question. Which variables are characters? Let's deal with that. Which variables are characters? You can tell me. Which variables are characters?
The 3. Look.
Mention them.
Log, OCC, and religion.
Very good. Which variables are numbers?
4 though.
Good. Which variables are integers? That's tricky. That's not.
Q and C.
The letter you are seeing here, which variables are integers?
Q and C.
Very good. Q and C. Okay. Now, which variables are floats?
P and M.
P and M. Very good. Now, you can check the information of everything we said, okay, by using the informational section. What command will you put there to check the information about the entire data set? What command? Who knows? Okay, you type df.info. Okay. df.info, and then you put bracket. And that's it. Once you run this, it will give you the information about everything. So it tells you that the Q is an integer, the P is a float, the C is an integer, the M is a float, and then the rest are all characters or objects. Job done. So it tells you that 2 of them are in this, and 3 of them are that, and then the 4 are this. So this gives you a bit of information that you need about your data. So you should always learn these things. Next one. You should find the dimensions and the size of your data. Okay. What is the dimension of the data? How do you find the dimension of the data? If you want to find the dimension, how do you find it?
So it's a row, total row, and then total column.
What command do you use to find the dimension? How will you write it?
df.shape.
Exactly. Okay. So now, so you do df.shape, and that will give you the dimension. Okay. In this case, it tells you that you have 40 observations and then 9 variables here. Now, 9 variables is included certain variables. For example, it's included the shop and the year. That's why you have 9. Other than that, that is not really the case. And now we can find the size of the data. So how do you also find the size of the data? df what?
df.size.
Very good. So you find df.size, then that will tell you that the size is just the rows times a column. The number of rows, the number of observations times the columns. Okay, so that's 4 by 9. So that's it. If you want the results to show for both of them, you can print it. Okay, you can print. You can bring P in front of each one of them, print in front of each one of them, so that they will all, showcase your results. Because right now the other one is gone. It looks like one has, overshadowed the other. But once you print, they will all come. So one come on top of the other will show as well. Next question. Count and indicate the number of missing values. So how do you check whether or not they are missing values? How do you check whether or not? What command do you think you're going to use to check whether or not there are missing values?
df is now into brackets.
Doing it, and also there be na air chile.
There you.
What is the view? Are you typing it to chat to be giving it things or what?
This is what happened when you send the file up. I have to go through and find a way. I filled some of them already. Yes.
Okay, good. At least that's better. All right. So, guys, we want to find the count, okay, and then the number of missing values. So, how do you do that? Yeah, go ahead now. Since you're going to give the results quickly, let's do print, and then tell us what do you have.
So you can name it as missing value equals to df dot is now into bracket dot sum.
Good.
Yeah.
Are you done? Oh yeah.
So the total missing value is df dot is now dot is sum dot is sum dot sum dot sum.
You have to have this null dot remove this sum. I have this bracket show. Oh, I wrote the null twice. No, this null must have.
You have to bring the sum dot sum. Yeah. Dot sum before the sum. Yeah.
Oh, hold on. Let me see. df dot null into bracket this.
Dog is no is no.
Yeah.
You didn't bring the is.
All right. So that will give you the number of all the variables that you need. And you can see that there is no missing values in the sentence. So that tells you that you don't have any missing values. So you can now proceed and then do your work. Now let's proceed and do. So if you have this time for you, and you are going to have timed it in Sakai for you to be able to do this under timing condition, you should be able to run all of this. Yes, Agoda. Yes, Agoda, your hand is up. All right, so let's move on. So we are going to generate a contingency table, also called cross-tabulation table. Okay. In terms of frequency count. Okay. We are going to do that between location and occupation. Between location and occupation. So how do you generate a contingency table? How do you do that? Okay. You have to use a command which is called pd.crosstab. And what's the name of the guy who was? I want to see whether you were also able to do that one. Did you do pd.crosstab?
No, I didn't get to that place.
All right, no problem. Let's try that together. Okay. So you do pd.crosstab. That is cross tabulation. It's the same as contingency table. So work along with me. Work along with me. Okay. You do pd.crosstab and then you put into brackets, and inside a bracket, you are going to give your index. Okay. So you type your index equal to, and then we identify the index. Remember, we are looking at location. So you type the name of the data set and then put the location there. And inside that, you should have location, LOC, like this. So we've been able to create it for location, but we need to do the same thing for the column, because cross-tabulation means you must have one representing the row, and the one representing the row or the index, which is also called row, is that of the location. Then the occupation will be the column. So you type comma, you step out of the square bracket, type comma, and then do the column. And then for the column, again, just like you did for the index or the row, you do df square bracket, and then you type the name of the occupation. What name was that? It was OCC, right? Let me just check. It was OCC. I think so. It was OCC. So you type OCC, and then that's it. So we are going to actually look for that. We are matching cross-tabulation of location and occupation. That's what we are doing. And now we are going to create our contingency. Let's do that. Okay. There will always be some typos, so you just double check and be sure. It's supposed to be PD crosstab index df as the name of the data. The cross columns, not column. I missed the S. So it's columns. Because you're talking about we are saying that from within that DF data, pick the columns out of that column. One of these columns is called OCC. Okay, now let's run that. And there you go. So that will give you the cross tabulation of rural, urban against the different occupation. This is how you generate cross tabulation. It is two categorical variables at a time. Okay? It's two categorical variables at one time. At one time. Okay. So now that you generated, there are some questions to answer. You are told to answer how many shops are in the rural areas. So let's answer that. Just look at the results and tell me how many shops are in the rural areas. Who can guess? How many is there? The numbers are there. How many shops are in the rural areas? Come on, you should be able to guess it. Is that it?
So I think there's no missing value, so it'll be 40.
No, watch it. In the rural areas. I didn't say in the both rural and urban. If I had said both rural and urban, then you know the rural and urban come together will make 40, right? But this time I say rural areas. Let me drink water. So all you got to do is 20. All you got to do is to come and look at the rural section here and count. That's all. Count the rural. And you know that they are what? 20. That's it. That's how you find how many shops are in the rural area. Next question. How many are in the urban center? Coco.
20.
20. And I'm sure you can get the picture now. Now, how many teachers are in the urban areas? Who can tell us? How many?
12.
Excellent.
Urban, 4. Urban is 8. Urban is 8.
Good. So who said 12? Is it the same person who said 12? 4.
Yeah, I was correcting myself.
All right, okay. So urban is 8. And how many teachers are, how many traders are in the data set? How many traders are in the data set?
12.
So that one is easy. Okay. And finally, how many fishes are in rural dwellers? How many fishes are rural dwellers?
4.
Good. Very good. Guys, this is a small data set with few categories. The one I'll give you, the categories are like 8 against 9. So you should be able to identify. I mean, it's a matter of just thinking through and identifying the mechanics of all of it. So just understand what we've just done here. This is a cross tabulation. You should be able to know. It helps you to get the classifications of things within the data set, the classifications. Okay, now watch this one. The first one was saying that you should generate a cross tabulation table, which we've just done. The next one says, look at the question. It says, yes, Richmond.
Okay, please, how did we get 20?
So many times without talking. What's the problem?
No, I tried talking and then it seems you didn't hear me. Please, how did you get 20 for the first question? How many shops are there in the rural areas?
You count all those in the rural section here. You count. Count 4 plus 4 plus 12.
Yeah, I understand, but okay.
All right. The next thing is the cross tabulation matrix, which is the same as a contingency table. But this time you are doing it between religion and location. And then it says add percentages. So when the things are many, you don't want the actual values. So you can use percentages because there's a limit of percentage, which is 100. So how do you do it this time with percentages? Let's do that first before we also address the question. But you see, this time it's not about location and the other one. It's about religion and location, not occupation. Religion, okay? So that should tell you that which one will come first. Sorry, did I say religion? That's religion, right? That's what I said. Yes, okay. So let's do that. So first we need to create a couple of things, okay? So let's create something we call counts. We're creating a count and then do equal to count equal to, again, we're going to use that same PD cross tab. Okay. Then the name of the data. The name of the data is Jin. So you type Jin. And then we are looking at religion and what? What name was given for religion? Is it REL, right? I want to believe so. So you bring your square bracket, and inside that, you bring your apostrophe and type REL, okay, for religion. Okay. You do for REL for religion. You bring a comma after the square bracket. Then you do DF, the name of the data set. And we are going to pick the next item, which is what? Location. Location is LOC. So you do this, and then bring your LOC for location. That is the first part. Okay. I'm not going to run this yet because we are creating something, because I want to add a percentage because it says add percentage. So still in that cell, let's add a percentage. So let's create the result. Let's create a result equal to the count that we had. So we are going to add something to the count. Okay, the count is what we did before, but I want to create a copy of the count, and then you can bring your bracket and make it as a string variable, okay, by using the .as type. So you can say that .as type, and then after using your .as type, you indicate that it's a string variable by typing str. And now we can go and add whatever thing that we want. I want to give it a sort of a title. You can say plus double apostrophe, but let me give it a space so that double apostrophe, and then you bring your bracket, and inside that bracket you do plus. I know it's long, don't worry, when I finish you understand. If there is, Rebecca says near mirror hand have a fact. There is an easier one you would have actually gone for it. So you do count. So let's do the count. Count dot we divide, because we are going to do division percentages, okay, by each of the counts before we multiply by 100. Okay, so divide the counts after you've taken the sum of the axes. So you add the axis equated to 1. And then the second axis is 0 because we are taking a sort of a dummy. When you have sat down, normally and then you multiply it by 100. When you have sat down, get a picture. I promise you on that. Let's round it. We can do a rounding of the whole result. Let's round it to a certain round. Let's round it to a nearest 1 decimal places. Okay. So let's round it to 1 decimal place. And then make that one to as dot type with the same string. The same string, str. And then you add the apostrophe and the percentage to it. Now I can close it and I put all in the double apostrophe. I just put I'm correct. All right, I am. Leave. Let's print the results. So result. So that should give you, hopefully. Okay. Oh, I made a mistake. I decided to bring Jim here, and I can see. You see, I'm reading the error it mentions. So that is what you got. Always have to check some of these things. So let me call it DF. There you go. Yay. Okay. So again, you just have to familiarize yourself a little bit with it. But again, this is just to guide you. So what we've done is that we've been able to publish religion here against location there. Okay. And then we now know clearly that, and we've not only given the values, We've also given percentages in brackets, okay, which is what the question is asking you to do. So what do all these nonsensical buffooneries mean? Well, the only way you can understand what all of these mean is by looking at some associated questions. How many Buddhists are in rural areas? Who can answer that? And let me see. How many Buddhists are in the rural areas? Remember, each row 100%. Not each column, but each row. Sorry? How many Buddhists are in the rural areas?
8.
8. How many percentage is that?
66.7.
So you could be asked, after you've generated it, you could be asked to give the actual number or to give the percentages. Okay. How many urban dwellers are Muslims? How many urban dwellers are Muslims? You see, now that you've generated it, you can answer the rest of the questions. How many urban dwellers are Muslims? Oh, by the way, in case whatever I'm running, I've been told that you guys have been baptized in the sea of good Python. Okay. So I'm assuming that you have the prior knowledge, and that's what I was told. This is a second semester course, so if not, just go and familiarize yourself with some of the things I've given you, and just understand a few things. You'll be fine. How many urban dwellers are Muslims? What answer will you give?
4, which is 25%.
And what is the percentage of Christians in the data set? I think that question is a very naive question, right?
100%.
Yeah, it's 100%. I think it shouldn't be, because obviously there's going to be 100%, but the actual number is 12. Okay. So there are a series of questions you could add. For example, I could have asked you, what is the percentage of Muslims what is the percentage of Muslims in the rural area? What will you say? What's the percentage of Muslims in the rural area?
12%.
12%. Very good. Hey, no, that's not 12%.
75.
75%. Okay, that's what we are looking at. Yes, Joseph.
Doc, please, the last question, which says what is the percentage of Christians in the data set? I'm just thinking, don't you think the question is basically requesting
But I
us
just
to
said that
give the
question is
percentage?
naive. You've forgotten what I just said.
Yes, but I'm just thinking, Doc, because there's a total data set of about 40. So maybe with everything, it's just the question sort of wants us to determine the percentage of Christians in the entire data set, combining the rural and urban for each of the religions or for all the religions.
I mean the results we have.
Yes. Yes.
Joseph, so you see the rural areas, the percentage of Christian is 0. They are all in the urban area, which is 100% in the data set. I think that's what we are seeing here. So if you add 0 to the 12, which is 100, then it's still 100.
But it seems to have a point he's saying.
I'm not sure. Yeah.
I don't think you understand me. Forgive.
Oh, I understand you.
All I'm just
I understand
right.
you. Don't worry.
Sure.
He doesn't, but I understand what you mean. And you're right. Because if we use the entire data set, then it makes it very weird to actually do that. Anyway, these questions, I just created these questions, some of these questions. I was asking so many questions and they came out. But ideally, for you to be able to get this, it should be the percentage. The question should be, what is the percentage of Christians in the urban center?
Rob.
Yes.
Please, on what Joseph said, when we look at the results, when we look at the result carefully, we see that in the data set, Buddhist is 100% as well. Even Muslims are 100%. So the question is just not right, not that the answer is wrong.
Exactly. That's the point he's also saying, and that's the point I agree with him. The answer is correct. It's a question that is not correct. Okay. So that ideally, the question could be something like, what is the percentage of Christians who can pose a very nice question? Joseph, can you pose a nice question? But you will not get the answer you are looking for here, Joseph. You know that?
Yes, that's
get
where
the answer you are looking for. Really.
Yeah.
But let's take it out and just say, what is the number? Maybe that will help. What's the number of shops that Christians buy from? How about that?
That sounds like
that sounds ideal, isn't it? Yeah, that's good. At least, like I said, I was just asking so many questions. I had to create so many questions. So maybe this one might, and we'll still get a 12, isn't it?
Right.
Okay. Now let's go to the next one. Create cross-tabulation heat map. Okay, so you can create a heat map, and I'm sure you all know heat map. Do you guys know heat map? Do you remember heat map? You don't, let me know. Do you remember?
Yes, Prof.
Oh, you do? Okay. You guys remember heat map, that's good. Okay, let's quickly do that. CT. Okay, let's call it cross-tabulation. Okay, just going to create that PD cross-tab again. Okay, and just use the index. The index is equal to DF to bracket, because remember, it's the same thing that we are doing. Equal to DF, left and right bracket, and then we'll have, it's between religion, right? So we are going to do, REL, step out of the bracket, comma, and then you do for the columns occupation, because you are talking about occupation. So column equals to OCC for occupation. Okay. I missed my DF. Let me bring my DF. OCC for occupation. I need to close the bracket. Let me see. Yeah. Okay, so that's the first part. Now let's create a heat map of that. You can use Seaborn to do your heat map. Okay. So Seaborn is SNS.heatmap. It's just something that is nice. It's just beautiful to do. It's not really part of what I want to do. Let's annotate it as true. Okay. As true. And then let's format it to D. Let's format it with D. And then let's use blue, CMAP. Let's CMAP it. These are all just addendums to just color. You can change different colors that you want to add with blues. You can use another different colors that you want. So this is going to supposedly, supposed to generate a heat map for us. Yay, you got it. So this creates a heat map of the same thing that we have been doing, but just in the form of a picture. So you can know how many Buddhists, are fishers. There are 8 Buddhists who are fishers. There are 8 Christians who are fishers. Okay. And then there are 16 Muslims here. Okay. There are 16 Muslims within this particular environment. So this is just a heat map of something we've already done. Let's go to the next question. generate a descriptive statistics of the data set. That's the most important thing that we are doing for today. Okay. So we're going to generate a complete descriptive statistics of the data. And I know you all know how to do that. So who can tell me? How do you generate descriptive statistics? It's very simple. The name of the data is DF. So it becomes DF what? Dot. No? Nobody?
Dot describe.
Dot describe. At least you know. Okay. You always get someone who knows. DF dot describe. That's it. And then you can generate whatever. Oh, what is happening? Oh, I should bring a bracket. Sorry. There you go. So df.describe, and that gives you your complete. Now it's going to give you descriptive statistics for just the numerical variables, and I'm sure you know this already. The year is not important, so you know the year, and you can see clearly. So the average quantity demanded of gene bitters is 175. That's the average quantity demanded of gene bitters. You can see that. There are several questions you could be asked here. Okay? Now, when you look at the mean and the standard deviation, what would you say about the size of the quantity demanded? What would you say about the size of the quantity demanded across the shops? What would you say, given the mean and the standard deviation? What would you say? Would you say that they are equal sizes, or they are too big and too small sizes, or they are very close sizes?
Too big and too small sizes.
Are you sure? Too big and too small sizes happens only when the standard deviation is more than the mean.
Okay.
Now, the standard deviation here is way less than the mean. The standard deviation is 29. The mean is 175. Okay. So it means that these firms are of similar sizes. In fact, they are very, very similar sizes. And if the standard deviation here was 0, then we can even say that they are all of the same size. If the but this tells me that they are very, very similar sizes. And normally, one way you can detect some of these things is look at the minimum value and the maximum value. The minimum is 130, the maximum is 220. It's not too far apart from each other. So they are of similar size, not too big, not too small. For only the Q, you can do the same thing for the P. If I look at the prices, okay, the mean and the standard deviation, it also shows clearly similar, the same thing as the rest. Now, the variance was not packed, so you can generate the variance on its own. You can generate the standard deviation on its own. You can generate the mean on its own if you want. So you just do df, okay, dot mean if you want to have the mean, then bracket. You can also do df dot std for the standard deviation, then bracket. Then you can also do df dot variance for the variance. You can do that for all of them. And you can run this. Let's run it. And then it will give you for each one. So these first few ones are for the means. These next ones are for the standard deviations. And now you can get ones for the variance. So if you want individual ones, you can do. In fact, if there's anything else that you want, let's say that we wanted a coefficient of variation. Let's say we wanted a geometric mean. Let's do that instead. No, hopefully. df dot, I don't know what name they give to it. If it had been Excel, it would have given it to us. Yeah. They don't call it geometric. I don't know what name they give to it. Yeah. The name is not geometric. Or maybe it's gem. Or maybe it's geom. I don't know. I've forgotten the name. So whatever name you have for it, you can use that to get it. Okay. The last and the most important one I want to talk about here is the coefficient of variation, which you might need sometimes. What is that? You are supposed to find the coefficient of variation. Okay. What does it do? It is used to compare the relative variability of the data set with different units or means. For example, let's say that you want to look at the volatility of two investments, how volatile the two investments are. Let's say Google investment, Apple investment, and one of them has got a higher mean, average return than the other. So one of them is giving you more returns and the other is giving you less returns. But the one with more returns, it also means that you will have more risk, isn't it? The higher the risk, the higher the return. So it's giving you more return, you're happy, but now you need to measure the risk. What do you use to measure the risk? The standard deviation, okay? The coefficient of variation, okay? So you can bring that into the picture to be able to look at it. You can use this also to compare the precision of instruments or methods. So let's say that you've gotten method A, method B, method C. You can use it to measure the precision of those methods, okay, that are used to measure different things or operate on different scales. In finance, if you have a lower coefficient of variation, it tells you that this thing has got a better risk-return trade-off. Because when you look at it, the coefficient of variation is actually combining two things. What is it combining? The coefficient of variation is using two things. It's dividing the mean, the standard deviation by the mean. The standard deviation. So you need a standard deviation, which is a risk. You need a mean, which is a return. So when you use the coefficient of variation, it is telling you the risk return trade-off. And if it is lower, because the standard deviation is the numerator, the mean is the denominator. So if the whole thing is lower, it means that risk has come down. So it means that you have a better risk return trade-off. It's a very, very good concept. You can also use it to choose between methods by comparing consistency in producing results. So how do you calculate the coefficient of variation? That's the last thing you're going to do. So let's call it CV. Let's do that together because you will calculate this and explain it in your workout. So CV is equal to, let's find the standard deviation. Let's bring the bracket first. And let's do the standard deviation is DF STD bracket. Bring the dot, DF dot STD bracket. Then let's space it and be divided by DF dot mean, and then you do bracket. And then close the bracket or step out of the bracket. We want the answer in percentage, so let's multiply it by 100%. That's it. We can round the answer. Okay, so let's print the results, but we want to print the results in 2 decimal places. So let's say CV that we are going to print CV round, step out of the bracket and do 2 decimal places. Hopefully, yeah, that's it. Then you round it. Yeah, I knew there's a typo somewhere. Let me share. CV wait. Okay, I know why. So it's supposed to be round. This round. No. I should bring this one rather. They should all be inside. Okay. Then inside should be 2. Yep, it should be like this. There you go. So you're able to get the coefficient of variation for each of the variables that you are looking for. Remember, you are dividing the standard deviation here by the mean and multiplying it by 100. Okay? So the coefficient of variation for each one of them is done this way. This is descriptive statistics, though. We've not gone to correlation, we've not gone to all of this, which we shall do. But this is descriptive. We can put everything here together. I've given you this whole command. Everything we did, okay, we can compute all of the statistics for everything together. So I've defined each statistics here for you. Combine everything, the count, the median, the mode, everything that you want, we can define all of them. So there's a kind of a standard you can create. Even those that are not in Excel, you can bring some more, you can add up to this whenever you want, and you can do that. Then after that, you can create a data frame for it, okay? And then you can run the results. So this is a command, and now let's see the results by using this final summary. Let's print the result with everything we have created at the top here. Let's print the result. And that will give you this beautiful result. So at this stage, you can see that we forget about the first column. You can actually save this and export it also to Excel. You can now see that you have the mean, you have the median, you have the mode, you have the variance, standard deviation, coefficient of variation, skewness, kurtosis, interquartile range, everything that you will ever need as far as descriptive statistics is concerned. You got it all covered. Ladies and gentlemen, you should be able, if I give you a data set, you should be able to generate the descriptive statistics for as many variables and make practical interpretations of all of them. What a day. What a day it's been. Oh, somebody was giving me the geomean, which was G-mean. Good. So at least you got that. So ladies and gentlemen, that is how you execute descriptive statistics. But more importantly, how you interpret them is also very important. Next time, we are going to learn correlation. Okay, correlation, significance of correlation. And then we shall do regression in that regard. That brings us to the end of the entire caboodle.